cloud. Okay, now you can start.
Great. Okay, so welcome everyone. Thank you for coming today. Quick background on kind of myself and what we're doing here. And I'd be curious to hear also what interested you guys to come here. But so, my name's Brendan. I have a background in computer science and economics. And I used to work at Capital One, and then about a year and a half ago, I left to work in the blockchain space full time. The way I did that was that I taught myself to program Solidity smart contracts, which are the back end for blockchain-based applications that run on Ethereum. And there has historically been, I would say, significant demand for that within the blockchain space. And then I kind of use that as well as other tactics to just find work in the space, projects to work on, and really leverage that to grow what I was able to accomplish. And so for the last year and a half, I've been essentially running a business where I'm the main blockchain technical consultant. I work hands-on on projects where I'll either join their team or work remotely, helping them develop blockchain applications, or just advising their tech team on roadmap and kind of doing the architecture and planning around the project. Or if it's a bigger programming project for a company that has no technical resources, I'll kind of assemble a team of programmers and manage them as they build the product and deliver it. And so in that way, I'll act as kind of the in-between between the client and the team. Okay, so that is my background. Does anyone have any questions before I jump into the day? All right, let's see, I'll make it full screen here. Great. So here's the general overview for today, the general outline. I'm going to kind of just pick and choose as we go because we only have 20 minutes. Please, if you have questions throughout, interrupt me. There's only a few people here, so I think the best thing for you guys would be for this to be interactive. So blockchain overview, what is a blockchain and how does it work? I don't know how much you guys know or what brought you here, but I'll keep it kind of high level. Feel free to read this or listen to me or whatever you want. So essentially, despite the fact that there's a lot of debate over the origins of blockchain and a lot of kind of proposed academic engineering protocols and applications that resemble blockchain as Bitcoin envisioned it, the general idea is a network or a protocol where nodes in the network or entities are able to share data without the use of a central coordinator. Sorry, could someone please mute their mic? There's just a bit of background noise. I think someone unmuted their mic there. Okay, I'll just keep going. So yeah, it is, the idea revolves around the sharing of data within a network without the use of a central coordinator. And so the first project to kind of successfully implement this in a way that attracted people to the network and grew the network was Bitcoin. And they kind of envisioned the protocol as they set it out in the Bitcoin white paper. And to me, the real innovation of Bitcoin was using currency as that data that's being transmitted without a coordinator, and then having let me explain this. Having mining as the solution for how you distribute the cost to run the network throughout to different people, because without that, there's really no way to ensure that someone's not going to just get a majority of the power in the network and then have control over it. But with Bitcoin, the idea is that were someone to do that, it becomes cost prohibitive because it would cost billions of dollars to take over a majority of the hash power or mining power in the network. And by the time you did that, because the protocol is transparent, the value of the currency would crash, and then it wouldn't be a profitable thing to do. But anyway, that's kind of a little bit of blockchain background. So this kind of just goes over what I was just saying. Every node in the network that is running the mining software and hardware, if they have a fully synced node, that means they just have a, someone please mute your mic. It just means that they have the record of all transactions in order that have occurred in that blockchain. And so that's how they can come to consensus on what transactions have happened and what balances everyone has, because they know every transaction and every amount that was transferred between two addresses. This is kind of just reiterating that. So this is a blockchain that's being implemented with currency as the central type of data that's being transmitted. So person A wants to send money to person B. This transaction is represented online as a block. The block is broadcast to every party in the network. So this is a little off, but basically each block will contain a number of transactions, and then there's a preset amount of time that passes. With Bitcoin, I believe it's at 10 minutes. And every 10 minutes, the block is going to be added to the blockchain. And so essentially in the protocol, the block node and the transactions within it, the block and the transactions within it are sent to all of the nodes, and they just check that the data within it is valid. And then once they have confirmed that it is, they add it to their ledger, to their record of transactions, and then it can be propagated throughout the network. So then once it's approved and added, then it gets added to the chain and the person can receive their money. And this is kind of just reiterating that. I'm gonna skip this because it's very scrunched up. So what can we use this for? What are some examples today? So there's a ton of dispute, both within the blockchain industry, within investors and developers. But so there are a lot of different use cases today. The biggest that I think you could argue are really utilizing full decentralization are as a means of currency and as a means of fundraising. A lot of the examples of blockchain use cases and applications that are talked about in media, like like voting or supply chain, those are using blockchain more as a way to append or pull or manage data and access to data. Sorry, there's just a lot of background noise. So some use cases and applications. Blockchain largely has value because of trust, transparency, and accountability. So essentially, because all transactions in the network are transparent, you can trust the protocol rather than having to trust any central entity to update records. And usually, so if you think of like a banking network, what they're doing when handling cross-border payments is they're buying or selling one currency and giving it to another person, and then they take a fee in the middle. Because if you're a business and you're, I don't know, you're trying to buy something from another country and you need that country's currency, they're going to ask for a pretty hefty fee for you to do that transaction. And it's going to take days to settle through a settlement house. And that kind of just slows down your entire process of buying and selling. And so cross-border payments, for example, would be a lot quicker with a cryptocurrency than with a traditional fiat payment gateway. So this is kind of more of what I was talking about earlier, but so in a traditional centralized web architecture, let's say you've got a front-end application and you are interfacing with it, and then it sends a request to a server to pull data or write data to the database, and it's a central database, and then that server will make a decision based on the permissioning of the person sending or pulling the data on whether or not they're able to do it. And then once if they're changing the data, if they've approved it, they'll just change the data. With a decentralized network, that data has to be essentially cross-checked across a majority of nodes within the network before data can be appended. And so by doing that, you've created a system that allows you to store, pull, or update data without having one central point of failure or one central point of storage. And that has a lot of implications in kind of application architecture or business models or business structures. And specifically within cybersecurity, as I've said, you remove having a central point of failure. It creates the potential to run or to create an application where users can have access to data that the company running the application doesn't necessarily store. So if you're, let's say, applying for a credit card and you need to give information, sensitive information to the bank in order to get the credit card, that bank will often have to store the information in order to run checks on it or give it to third parties. Whereas with this, you can create an application that distributes that information across the network and has the user interface with it directly rather than having it stored on your servers or third-party servers that are more centralized. And this is the same as what I was saying before. A dApp is just a distributed application. So it's a application whose back end is running on a public blockchain. And public just means that any node or any entity can join the network and be a part of it and either pull data or write data to the network. A permissioned blockchain would mean that there would be some authority within the network who approves or denies whether a node is allowed to join the network. And when a node joins the network, they're able to sync the transaction history, the ledger history, and then able to essentially run the protocol that approves transactions in the future. How are we doing on time? Okay. A distributed ledger is just a more general term. It is a kind of parent of, or a parent category of a blockchain. So distributed ledger encompasses public blockchains, permissioned blockchains, private blockchains. And it is also more generally refers to like a distributed or decentralized architecture. The main thing that a blockchain adds to a distributed or decentralized architecture is that cryptographic economic incentive layer, where by using mining, which has a fiat or fiscal cost to run a mining node through the hardware and the electricity of running it, you've distributed costs across the network, which, as I said earlier, makes it so that there isn't one central coordinator. So I know it's kind of hard to picture it when your mental model of a blockchain application is kind of vague, but essentially for most blockchain applications, they're only handling the back end of the app. And so what that means is they're handling how data is stored, accessed, updated. And so when you have a user-facing application, there has to be a front end, in most cases, a way for the front end to pull information from the back end. The back end might need to pull information in to make decisions about what to output. And so in a blockchain application, all of those kind of different points in the application's architecture are potential cybersecurity threats, because if that information is mutated or someone with some other incentive is able to change the information, then they can do something nefarious and unfair on the application. So it's, you'll sometimes see when you're researching blockchain that it's somehow more secure because it has cryptographic standards built into it, but that's not really true for blockchain applications, because they also have normal centralized parts of their architecture, such as the front end or the connection between front end and back end, that are still possible tamper points. The part that is kind of more secure is that protocol level back end, where data is just updated, because in order to mutate that, you would have to take over a majority of the power in the network, which, as I said earlier, would be kind of cost prohibitive. So this just displays there's been a ton of different hacks throughout blockchain's life, which makes sense. It's been around for 10 years. But yeah, this doesn't surprise me, $1 billion in hacks in 2018. Both through, a lot of them are through the back end of blockchain applications, so smart contracts that have been written with vulnerabilities in them, but also through more standard cybersecurity issues of a centralized application. So you'll see exchange hacks are very common, because those, for most exchanges, it's kind of just a standard front end that connects to a back end. And so that connection point is vulnerable, just as it is on any other application. But I'd say because blockchain today, since the biggest use case is cryptocurrency, and it's a new kind of immature market, we've seen a lot of bad security practices and a lot of vulnerabilities. And since it's just money is being transmitted all over the world using blockchain, it makes it a big target, because if you're able to hack into that, you've got cryptocurrency which you can sell and immediately monetize. Whereas with other applications, if you hack in and get their data, that still has other steps needed to turn that data into money if you're a hacker. But with crypto, you just sell it. So, shoot, we're running out of time. I'd mentioned, so 51% attack, that's just when a majority of the mining power or hash power in the network is taken over. And if you control a majority of the mining power in the network, you're able to change the data of that network, because it's supposed to be a transaction log that's continuous from the start. But if you can change the data and say, oh, a month ago, I actually had $1 million, and then make it true, then you can kind of undermine the value of the network and also change your balance. Yeah, I'm gonna keep going. So I'm going to skip over the demo right now because it's been about 20 minutes.
Yeah, Brandon, I mean, you don't need to worry about the career part because they can also read the career part slides. I can send them to you. Just focus on your demo, and for 7 minutes, that's it. That's good.
Okay. So this is all I was going to do. It's a very simple one. So just a quick intro to the demo. So what I do as a developer mostly is smart contract development. A smart contract is kind of, all it really is a piece of code that runs on a decentralized protocol like Ethereum. And so I write smart contracts, and let me think of a good way. So if you guys know ERC20 or Ethereum-based tokens, those are all smart contracts. If you wanted to create a voting application that was running on a public blockchain, you would just write a smart contract that tracked the votes of different addresses, and addresses representing different users, and kind of executed the functions you would need in a voting application. So you can just think of a smart contract, as it says here, as code that executes on a blockchain. And so there are a lot of different levels of quality that you see in smart contracts developed. And it's been an issue that people, because you're directly dealing with money, but if you have kind of smart contract code written by someone who doesn't really know the security standards, or written by a team that doesn't allocate the resources to get that code checked for security bugs, you have big vulnerabilities. And oftentimes people post their smart contract code publicly so that users can trust that it does what they say it does. And so if it's not perfectly secure, your code is public and people will read through it and then exploit problems as if they find them. So one thing you can do, usually when you're done developing, the first thing you'll do is run it through a bunch of security tools. So Consensus, the company behind Ethereum, has a bunch of different security tools that I've used in the past, and a ton are being made today and improved. These are a bunch of different ones. They're mostly static analysis. So they'll do very simple tests and look for patterns in code that represent some common problems, but really they're not robust enough to replace a manual audit by an expert. If you really want to write code that's going to be used to transact large volumes of money, you need to allocate it to an expert. But this is a static analysis tool that I've used in the past. I've pasted in a code block from some code that I've written for a blockchain token. So now it's running and it's going to kind of just go through my code. Hopefully there we go. And it'll look for patterns or issues. And let's see. So you can see lots of issues, and I have this code running on mainnet actually. But this is normal for anyone who's coded in the past. They'll know that compilers always have issues that they find. But this is pretty good. So it's saying locked money. Let's see. Contracts programmed to receive Ether should implement a way to withdraw it. Yeah, this one's wrong because I have a way to do that down there. So that's also the issue today with static analysis tools. When I'm doing, before I deliver a blockchain application, when I'm testing my own smart contracts, I will go through all of these to make sure they're wrong. But usually they're like, if these, so these are the type of errors where the code is able to compile and run, but it wants to note the errors for the author of the code just so they can kind of double check it. But they're oftentimes kind of incorrect. So let's see, extra gas consumption. So this is saying, so gas on Ethereum is kind of the unit that is used to measure the amount of computing power that a piece of code has to use in order to execute.
Brandon, one quick question. So do you think the tools that you're talking right now can be used for Hyperledger too?
These tools cannot, but Hyperledger definitely has similar security tools. I mean, so these are, you know, anyone who knows basic cybersecurity practices will be kind of familiar with the fact that there's always a bunch of cybersecurity tools, some of which are good, some of which are bad. But at the end of the day, if you really are doing something sensitive, you have to either make your own tools that are kind of custom built for what cybersecurity threats you have, or you bring in a third party who's an expert who can do cybersecurity testing. These are just kind of ways to catch any low-hanging fruit, but Hyperledger definitely has similar tools.
Oh, okay.
So yeah, that is the basic.
So another quick question, Brandon, is that, so based on what you're telling me, is this cybersecurity testing is going to happen while you are programming, or you have to do it once the application is developed?
You can do either.
Okay.
This is just running pre-written tests. I'm sure it has a bunch of other tests that it didn't trigger. Pre-written tests on the code. So you can run it through that as much as you want. Also, like, so I use Remix sometimes. This is an internet development environment, IDE. And Remix runs tests on the code as you write code. But again, they're really not perfect, because the most dangerous cybersecurity bugs are the ones that are just complicated enough for developers to not catch them. Just complicated enough that they're not caught by tools like this. So developers think they're safe, but then they're possible to be caught by a person. So I would say you can't really, you have to know cybersecurity topics well enough to really be able to test your code. These tools are just a way to kind of get a little closer.
Then one quick question is that, have you seen situation you see the conflict between different tools? Like, for example, you test your application with tools A, it gives you some error, and tools B give another error, and the errors have conflict. Have you seen this?
I have seen that. And that just points to, I mean, I know a lot of people working on cybersecurity tools for blockchain, because compared to more standard application development markets that are more mature, like, you know, the market for building just normal web applications, like, that's been around. People have been doing that for a long time. And so the tools to look for bugs in normal Python apps or JavaScript apps are a lot better than the tools for blockchain apps. which kind of creates a little bit of an opportunity for blockchain cybersecurity experts because the tools aren't as good, so there's more opportunity for kind of hands-on work.
Oh, that makes sense. So, Brandon, I think we are quite, we are almost done with the timing. So, I just want to open up for like a few minutes for if you have any questions, they can bring up their questions. So,
anyone have any questions?
Someone asked, what is SOL?
That's Solidity. So that's the file type for a smart contract. .sol. Yeah, that's what you name a Solidity smart contract file. And Solidity is the programming language for Ethereum. Hyperledger is a competing blockchain that was created by IBM. And so it's a permissioned blockchain, meaning that the different nodes that can join it, or you configure it so that there's kind of a central authority who can decide which nodes join the network. Any other questions, guys?
Yeah, so thanks again, Brandon, for your presentation. It was awesome. I learned a lot, even though I don't have any background in cybersecurity. It was very helpful for me. And just for everyone that interested to learn more about the blockchain cybersecurity, we have classes for blockchain cybersecurity specifically. And then someone asked, is the syntax for the security code, such as SOL file you are showing us, the same for all blockchain apps?
Is the syntax for the security code? What? I'm not sure what you mean by for the security code.
Sorry, I meant the actual code, that like the function balance of, like, I've never seen anything like what kind of language is that?
Oh, this is Solidity. So Solidity is a custom built language
for Ethereum, right?
For Ethereum. So that's kind of why Ethereum has an edge. So Ethereum, let's pull it up. This is CoinMarketCap. This is a way to see the biggest cryptocurrencies by market cap, so by the value of their cryptocurrency. Ethereum is number 2, Bitcoin's number 1. Ethereum was the first really robust blockchain platform. So that means, so what a main difference between Bitcoin and Ethereum is that Bitcoin's protocol runs with Bitcoin as the data that's being transmitted between people. Ethereum can run with different information being transmitted between people. And so Ethereum can run applications, whereas Bitcoin is just running with its currency. And so Ethereum was kind of pioneered with its own programming language that's somewhat based on JavaScript. And so that's why the syntax is kind of unique, but it has its own compiler. And for anyone who doesn't know, making a compiler is a big undertaking. It has a unique protocol and has its own programming language. And so that kind of gave it an early edge among programmers.
Thank you for that explanation.
Yep.
Yeah, again, thanks again, everyone, for this presentation. For everyone that's interested to learn more about, Brandon is one of our instructors. Actually, he teaches blockchain cybersecurity as well as blockchain, the Ethereum Solidity of classes that we have. And so we have classes for Solidity and Ethereum, as well as Hyperledger and blockchain cybersecurity. So if you're interested, just feel free to message me, meet up, or on the website, and we'll be happy to talk more about your classes. So everyone have a wonderful weekend, and I just want to thanks everyone for attending this webinar.
And I also just put my email in the group chat. If you guys know anyone who wants a blockchain application built, or anything kind of related to any of the services I mentioned earlier, feel free to shoot me an email and we can have a chat.
Yeah, thanks, Brandon. Yeah, especially cybersecurity aspect. So thanks, everyone. And we look forward to seeing you in our future webinars. Thanks.
Great. Take care, everyone.